Alright, today we're going to continue in section 10-2, measuring angles and arcs. And I'm going to do examples 3, 4, and 5. And then I'm going to give you an assignment. And then today's assignment and Monday's assignment and this entire section of the book, 10-2, is your study guide for your quiz tomorrow. Clear? Okay, then you can make the quiz up when you get back. Tomorrow's quiz makeup will not be available online, so you have to do it in person. Everybody understand what's going on? Yes. You're going to have a quiz on this section of the book, and that's it. So your study guide or your practice is all the practice problems in the section or the stuff that was assigned Monday or the stuff that gets assigned today. Make sense? Your study guide's basically page 706 through 714. And the answers to all those odd problems are in the back of the book. Alright, so example 3 on the top of page 708, you're asked to find each measure. And you are given a circle graph. And this circle graph, A, B, C, D, E, F, looks something like this. And each piece of the graph has a percentage value. And another 14%. And let's see, the first measure you're asked to find, the measure of arc CD. Okay, so just be careful when you're solving these types of problems. When you have a percentage as a angle measure, they're telling you that this angle measure right here, this central angle, C to D, we're looking for this arc measure, arc CD. In order to get arc CD, you need to know this central angle measure, okay, which is the 18%. But it's 18% of 360. Okay, so to find the measure of arc CD, you take 0.18 and you multiply it by 360. And that's 64.8. Now, that is in degrees. Alright, so the measure of arc BC. Arc BC. Well, that's the same as arc CD. They're both 18% of 360, so that's 64.8 as well. Degrees. The measure of arc EF. And E to F's right here. 14% of the circle. So you got 0.14 times 360. .4 degrees. And then let's do the measure of arc AC. Alright, the measure of arc AC. That's starting at A and going directly to C. So look, it's a little bigger portion of this circle. And in this case, you would have to combine your 20 and your 18%. So now your 20% plus your 18%. You got 38% of 360, or 0.38 times 360. And that's 136.8. 0.8 degrees. So any questions on finding an arc measure? An arc measure when you're given the central angle as a percentage. It's just a percentage of 360. Alright, look at example 4 on the bottom of that page. You are finding each measure in circle F. When you are given these types of problems, or this type of problem, when you're going to be asked to find different measures in this circle, the first thing I would do is I would fill in all of these central angle measures. If you do that first, and then use a highlighter or a colored pencil later, it makes these much easier and it eliminates mistakes. So you got this angle AFE that's 63 degrees, so angle EFD, well, you know that that's a 90-degree symbol. And A to C goes through the center of the circle, so it's a diameter. So this angle measure right here is 180 degrees. So in order to find CFD, you would take 180 and subtract the 90 and the 63. So that's the same as 90 minus 63, which is 27 degrees. Now if you look here in the middle where BE and CA intersect, those are vertical angles and they're congruent to each other. So angle BFC is also 63 degrees. And if on this right side A around to C is a semicircle and it's 180 degrees, well, C back around to A on the other side is the same thing. So this angle BFA is going to be 180 minus 63, which is 117. And now you have every central angle measure in that circle. So let's see what they ask you for. First thing is the measure of AED. Arc, AED. That's starting at A, going through E, and ending up at D. So it's this yellow one right here. And that's a combination of the 90 and the 63. So that's your 90 plus 63, which is 153 degrees. Everybody see it? Measure of arc ADB. ADB. Now look, that starts at A. It goes through D. And it stops at B. That's most of the circle. The only portion of the circle that it isn't is the 117. So instead of adding those four together, you can take 360 and subtract 117. And that's 243. Measure of arc CE. Starting at C, going directly to E. So we're going to start here, going to go directly to E. So that's a combination of your 27 and your 90. And 27 and 90 is 117. And then finally the measure of arc ABD. ABD starts at A, goes through B, and ends up at D over here. So that's all these three. So that's 117 plus a 63 plus a 27. And that's 207 degrees. So any questions about finding the measures of adjacent arcs? It's like adding segments together or adding angles together. You're just adding arc measures together. Now here, look, so far today we were finding each measure, right? And then before that, we were finding each measure. And now we're doing something a little bit different. Top of page 709. Finding an arc length. So we're going to say the length of an arc is equal to central angle divided by 360 times the circumference of the circle. This is different now. This is length of an arc. Length of an arc. So we're going to clean this up a little bit. We're going to say that the length of an arc is equal to x degrees divided by 360 times 2 pi r. And then this diagram is going to go with that formula. So if this is the arc length we're trying to find, this arc length L is equal to this angle measure divided by 360 times 2 times pi times the radius of the circle. Your central angle divided by 360 gives you a portion of the circle. And when you multiply that portion of the circle times the circumference, it gives you the portion of the total circumference of the circle as a length measure, not as a degree measure. So let's do some of these. We're going to find the length of ZY. That's arc ZY. Alright, and here's your 75 degrees, and this is 4 inches. So the length of ZY is going to be equal to 75 over 360 times 2 pi, and your radius here is 4. And your length of the arc will be in the same unit measure as your radius. So if you can go straight across here in your calculator. You take 75 divided by 360, hit equals, and then times 2 times pi button times 4, and you get 5.24, and that's going to be inches. 5.24 inches. Any questions there? The pi button, which is over on the left, 2 buttons below the green button. And I'm on second fix too. Good? Alright, in this second example, here's your given information. Now, when you're given this dimension, and it's right by the center of the circle, or it's right next to a segment that's going through the circle, it's representing the diameter. This 10 centimeters right here, when it's right in the middle, it represents this dimension, which is a diameter. And your radius is half of that. So the length of arc YZ is equal to, in this case, it's going to be your 130 divided by 360 times 2 pi And now your radius is 5. And again, it's a calculator problem. And I get 11.34. And since the radius was in centimeters, then the length of this arc right here is going to be in centimeters as well. Good? Alright, let's do one more. Alright, and now we need the length of arc YAZ. So this is a major arc, starting at Y, going through A, around here to Z. So you got to do a little math to get this central angle for YAZ. You got to take your 360 and subtract the 91. Alright, this central angle is 269. That's the central angle that corresponds to arc YAZ. So now we got 269 over 360 times 2 pi, and your radius is 9 feet. So your arc length is going to be in feet. So 269 divided by 360, and then times 2 times pi times 9, and that is 42.25, and that's in feet. No? I pushed the wrong button? 269 divided by 360, push equals. And then push times 2 times pi button times 9. Yeah, because 9 was your radius. Good? Alright, so your assignment for today is right here. This page 710, 6 through 11. And then I would review problems 1 through 5 and 16 through 23. This entire section is your study guide. Any quiz question or any problem in this section is a potential quiz question. Clear? Everybody all right with that? And your quiz is tomorrow.